Okay, so we want to also take this question. This question is in problem 2.3, question 9. Okay, we are given these two functions and we want to find the composite of f and g. That means we are putting g into f, and here we are putting f into g. Okay, so I will add, that is the question, but I will add and find their domains. Okay, so sometimes we can ask you to find the composite function and then the result of it, find the domain of it. Okay, so we are dealing with the first one, which is f of g, which is the same thing as f g. Okay, it's the same thing as this. So we are putting the g function inside the f function, and that will give us, anywhere we see v, we put g of v. Okay, so we are going to have 2 over root 3v plus 1 square minus 3. Okay, so anytime you put the composite function, please simplify it. You must simplify your expression. This gives us 2 over 3v plus 1 minus 3. Okay, this gives us 2 over 3v minus 2. Okay, that is the composite function. And what is the domain of this? The domain of this, because it's a fraction, we don't want the denominator to be 0. So that means the domain will be where this is not 0. Okay, which implies that if we solve it, equating it to 0, then we get 3v equals to 2, then v equals to 2 over 3. Okay, so we are looking for where v is not equals to 2 over 3. Okay, that is the purpose of solving it. We are solving it with equals to 0 in order to get where we don't want. Okay, so we don't want where v equals to 2 over 3. So the domain of this function is now negative infinity to 2 over 3 union 2 over 3 to positive infinity. So that is the domain of that function. That is the domain of that function. Okay, the second one, we are putting f inside g. We are putting f inside g. So we have number 2, g composite f of v, which is the same thing as g of fv. Okay, so when we put f inside g, we are putting f inside g, f inside g. Okay, so that will become root 3 into 2 over v square minus 3 plus 1. I think so. Let me check again. So we have plus 1. Yeah, minus 3 plus 1. Okay, so that is, then we must simplify that. To simplify that, we have, this is 6 over v square minus 3 plus 1. Okay, so we need to find this as a single fraction. Then we have this into v square minus 3. This is 6 plus the same thing, v square minus 3. Okay. So simplifying that, we have square root into 3 plus v square all over v square minus 3. v square minus 3. Okay, that's what we have there. And what is the domain of this? Again, don't forget, whenever we have the root, we don't want what is inside there to be negative. Okay, so I can have this plus, just like the way we did in our previous video, this must be greater or equals to 0. Okay, so if I solve this now, I'm going to be having 3 plus v squared greater or equals to 0. If I multiply through by this one, then I will have v squared greater or equals to negative 3. Okay, so v squared must be greater than negative 3. Okay, so then we are going to have v greater or equals to root of negative 3. We don't want that one. We cannot, for now, we cannot undo what is negative 3. Okay, because this is a complex number. Okay, so let's hold on to that now, but this one must not be 0. So at the denominator, we have v squared minus 3 must not be equal to 0. Okay, that means that if I solve this one, I'm going to have v squared minus 3 is equals to 0, then v squared equals to 3, and then v equals to root of 3, positive or negative of 3. Okay, so that means that v cannot be root of 3 or negative of the root of 3. Okay, meanwhile, this one, the one at the numerator will always be positive. Can you see that? Because this is 3 and this is v squared, so it will actually be always be positive. Always be positive. Okay, so that means the only thing we need now for the domain of that, so the domain now is that we have negative infinity to negative root 3 union negative root 3 to root 3 union root 3 to positive infinity. Okay, so that will be the domain of that. Okay, please ensure you understand.